In level 4, we will be solving absolute value inequalities. It's going to be similar to solving absolute value equations with an additional step. So like solving absolute value equations, first we have to isolate the absolute value, and then again we're going to split it into two different equations, or two different inequalities in this case. In example A, the absolute value is already isolated, so I don't have to get it by itself. It's already by itself. And then what I'm going to do is split it into two equations. The first side is going to be x plus 2 is less than or equal to 5. So I just keep it exactly the same in the positive case. In the negative case, where I take my 5 and make it negative, the extra step is that you flip the sign. So for my second equation, I'm going to get x plus 2. I flip my sign around and make it greater than or equal to, and then I change the sign to negative 5. So two things to change in your second equation. You're going to make the number on the end negative and flip the sign. And then you just solve both inequalities. So I start with my left-hand inequality, subtract 2 from both sides, and we get x is less than or equal to 3. And then in my other equation, I subtract 2 from both sides, and we get x is greater than or equal to negative 7. And then I graph it. So I start with x is less than or equal to 3. That's going to be a closed dot at 3, and less than 3 shades to the left. But I also want to see what's going to happen with my other inequality. So my other one is x is greater than or equal to negative 7. So it's a closed dot at negative 7, and the numbers that are greater than negative 7 are to the right. So this is a situation where it's shaded in the middle. And the official way to write that inequality is negative 7 is less than or equal to x, which is less than or equal to 3. Now in the next example, I do have to isolate the absolute value. So first I need to get the absolute value by itself. So I'm going to subtract 5 from both sides, and we get 4 times the absolute value of negative 2x minus 3 is greater than or equal to 4. Then I'm going to divide both sides by 4, and we get the absolute value of negative 2x minus 3 is greater than or equal to 1. And now that I've isolated my absolute value, I'm going to split it into two different inequalities. So on the first equation or inequality, I keep everything the same. I just take my expression, negative 2x minus 3, greater than or equal to positive 1. So I keep the symbol facing the same way and use the positive case, the positive 1. And then for my second equation, I always keep the expression the same, but I flip the sign, make it less than or equal to, and change the number to negative. So that's going to be negative 1. And then I solve both inequalities. So I add 3 to both sides. We get negative 2x is greater than or equal to 4. Then I divide both sides by negative 2. But remember, when you're solving an inequality, if you multiply or divide both sides by a negative, the sign has to flip. So we have to flip the sign in this case because we're dividing by a negative, and we get x is less than or equal to negative 2. And then on the other equation, add 3 to both sides. We get negative 2x is less than or equal to 2. Divide both sides by negative 2. Again, I'm dividing both sides by a negative, so I have to flip the sign. And we get x is greater than or equal to negative 1. And then I graph both of these. X is less than or equal to negative 2. Again, it's a closed dot. And less than negative 2 is to the left. And then the other part is x is greater than or equal to negative 1. So a closed dot at negative 1. and greater is this way. So this is a situation where it goes off in two opposite directions. That's an OR inequality, and that would be my final answer.